student at Mizzou with us today. Um, Levi's a passionate outdoor recreational enthusiast, conservationist, and specializes in aquatic, invasive, and endangered species research. Just a little background on Levi. After completing his Associate of Arts from Heartland Community College in Illinois, he transferred to Montana State University in Bozeman, Montana, where he completed his Bachelor of Science in Fish and Wildlife Ecology and Management. In 2022, he completed a Master of Science in Fisheries and Aquatic Biology at Murray State University in Kentucky. And then shortly thereafter began his PhD in Natural Resources with the Missouri Cooperative Fish and Wildlife Research Unit at the University of Missouri. He has also served as the Vice President for the North American Sturgeon and Paddlefish Society since 2023 and has served as the treasurer for the University of Missouri's Fisheries and Aquatic Science Society since 2023. And with that, I will let Levi take it away.
All right, yeah. Thanks for that introduction, Levi. So today's title of the talk will be Receiving the Baton in the Anthropocene Era, Results from 4 Decades of Missouri Lake Sturgeon Restoration. So yeah, just a little bit about kind of the aquatic journey here. Grew up in Illinois, also lived in Minnesota as well, up near you all, and also lived in Wisconsin for a few short years before moving back to Illinois and starting on the natural resource or fisheries research path. Worked for the Illinois DNR and then the Montana Cooperative Fisheries Research Unit. Worked for the Columbia Environmental Research Center. It's out of the USGS Fort Peck office in Montana on pallid sturgeon. And then served for 2 years in the War on Carp in Kentucky. And also enjoy volunteering on any white sturgeon studies that I can out in Idaho and Washington. So for my dissertation chapters, we're going to talk about the first 2 today, just for time's sake. But I'll just tell you all 3 of them here. It's what environmental parameters influence sites of spawning aggregations within the Osage and the Gasconade rivers, and then what environmental parameters influence the late summer and fall habitat use of age 0 lake sturgeon within the Osage and Gasconade rivers once again. And then the third one will be what thermal and depth ranges are the adult lake sturgeon selecting for amongst, different fluctuating covariates such as dissolved oxygen, flow, and season. So here in Missouri, we have 3 native sturgeon species, the first being the pallid sturgeon, which is federally endangered. That's pictured here in the upper right. And then we also have the lake sturgeon. They're state endangered, and they're actually recently reviewed just this year for being enlisted on the federally endangered species list, but did not get listed. And then we also have the shovel-nosed sturgeon, which are quite abundant throughout both the Missouri and Mississippi watershed. So what happened to Missouri's lake sturgeon? Reasons pertaining to the decline of, the once abundant lake sturgeon include nuisance killings and overharvest, anthropogenic stressors, and in 17 states or provinces across North America, lake sturgeon are listed as an endangered, threatened, or species of special concern. So in 1870, we kind of had the kickoff of the caviar boom, and the U.S. was the major caviar supplier in the early 20th century to Europe, and sturgeon were just harvested at unsustainable rates without regulation, which just decimated most of their populations within America. In summary, lake sturgeon within our state's waters were pretty much driven to be practically functionally extinct and were deemed incapable of recovery by their own means. So a little bit about Missouri's lake sturgeon history. They were listed as a state endangered species in 1974. And then in 1984, the lake sturgeon recovery plan was initiated and restoration efforts began. And to date, over 100,000 have been introduced to the rivers. I think in 2006, they started introducing them into tributaries of the Missouri and Mississippi River because of natal philopatry, which is just they will return to the areas of which they were born or remember, imprinted on to spawn later on. And then Illinois first released their lake sturgeon in 2023, so that's fairly recent. Kentucky was in 2018, and Tennessee in the year 2000. So the 10-year recovery plan that was initiated by the Missouri Department of Conservation has obviously been updated since then, and it has continued on over the decades. And I kind of would like to add the lead lake sturgeon recovery biologist has since been dead for, I think, 15 years now. So when you're dealing with such a long-lived species, it's important to take into account a lot of what we are doing with these long-lived species. We won't always be able to reap the benefits of, but the generations that come after us. So yeah, they're as I mentioned, they're just super slow to mature, which unfortunately means slower recovery times. And they are a long-lived species. Lake sturgeon can live up to 152 years and weigh up to 310 pounds and measure, upwards of 9 feet long. The females will reach maturity at ages 14 to 26, and males typically will reach maturity somewhere between 12 to 20 years. And then their survival rates from the egg stage to the juvenile stage can be as low as 0.002%. So they do have a prolonged spawning periodicity. Females will spawn every 4 to 9 years, depending on food resource availability. And then the males will spawn typically once every 1 to 5 years. And the year prior to spawning, the female will be in egg stage F2 or F3, meaning her eggs will start to take on a yellow pigmentation. And F1, typically they're white and pretty small in diameter. And the year that they will spawn, typically they will transition into stage F4, just meaning that they have that darker pigmentation, as you can see in that incision that was made on this F4 female. That means she's now gravid, and the girth size of her will be typically pretty noticeable. And something that's interesting about these species is they will kind of take an assessment of the conditions. If spawning conditions are unfavorable, she may begin follicular atresia, and basically that's just going atretic is what we call that, and she will reabsorb her eggs, and she'll deem that this year the spawning conditions aren't great. I'm gonna reabsorb these eggs that I've spent up to 4 years allocating energy resources for the gonadal development, and she may spawn a few years later, which is just very interesting. They're this Protagoras Idoparus species, and it takes up to a third of her overall body weight can be made up of these eggs. Obviously we can't show this here, but if you were to slit that entire abdominal region, she have folds of these eggs, almost all from her anal cavity up to almost the pectoral fins. So they are just bloated full of eggs. So a little bit about lake sturgeon life cycle. The adults, as I said, just depends on which publication you read. To 7 feet long, 250 pounds, 150 years old, prolonged spawning periodicities. But the habitat that they choose to select is typically this coarse substrate, which will have clean interstitial spaces with typically higher velocities to keep that interstitial space clean and to provide sufficient aeration for their eggs, which can be about 1/6 of an inch in diameter. And typically, depending on water temperatures, will hatch every 1 to 2 in 1 to 2 weeks. And this stage is by far the most vulnerable to predators. They're kind of this sticky, milky white egg that will stick to that substrate. Once hatched, they will settle into those interstitial spaces, and they'll remain there for some time until they've absorbed their egg yolk sac, and then they will begin the onset of drift, typically at night, since they are negatively phototaxic. And the larvae can be anywhere from 1/4 to a 1/2 inch in length, 0 to 5 months old, and they will continue that drift downstream until they find favorable nursery habitat while feeding on aquatic insects. And then you come to the young of the year stage, will typically be that 5 to 16 inches in length. You're half to a 1-year-old, and they're still eating those aquatic insects. And then in the juvenile state, this will be when they start to transition over to piscivory, but they will still eat mussels and aquatic insects as well as small fish. And they will remain in that juvenile stage anywhere from 1 to 26 years old, or whenever they reach maturity. And at that point, their humans are essentially the only predator to them, similar to adults, but they don't spawn quite yet. So that kind of brings us to my first dissertation question: is what environmental parameters influence sites of these spawning aggregations within these rivers? And so we're using acoustic tags, and we're inserting those into the sexually reproductive adults in order to track their movements. And so this is just a quick map from Barrel et al. 2018. We have the native range of the lake sturgeon, and then also these yellow dots are indicating known or at least documented spawning aggregations. So as you can see, and they're kind of the southern, what do you say, the southern fourth of the native range here. Very limited documented spawning aggregations have occurred. These lake sturgeon do travel quite a bit. This is Missouri biologist Sarah Pieper over on the Mississippi River near Mel Price Lock and Dam, which is near St. Louis. And this specific lake sturgeon is actually one that was tagged in the Chippewa River up in Wisconsin 10 years ago. This male was captured this year. And they were able to confirm that, yes, indeed, it was from the Chippewa River, and swam down to join a spawning aggregation here in Pool 26 of the Mississippi River. And here I've put together the star up here will start in the Chippewa, and then it'll travel down the entire stretch here down to St. Louis. So yeah, once again, starts up there. And each time that star moves, that is a lock and dam structure that fish had to move through, which is just remarkable. It was able to make that 650-mile migration. So here's a broad map of the Missouri River Basin. Those of you who aren't familiar with it, it's one of the larger river basins in our country. And my study rivers are the Osage and the Gasconade River down here on the lower right. And the Osage River, even though it looked pretty tiny on that map, is actually the third largest river in the state, being third to the Mississippi and the Missouri River. And it actually spans out into Kansas, but at river kilometer 132 on the Osage River lies Bagnell Dam, and that holds the Lake of the Ozarks Reservoir. And my study stretch is that lower 132 river kilometers. And then the Gasconade River is my other study river that I've mentioned. This is actually the longest free-flowing river within the state of Missouri. So it's kind of interesting. You have your regulated river, then your unregulated natural flow regime river that we're able to study the movements in. And so here's a map of Missouri with one confirmed spawning site, and that's over when Sarah Pieper's territory. And the first documented spawning occurrence was actually 31 years after the first restoration effort began back in 1984. And there is talk of the potential of the native strain, our southern native strain, being left in Lake of the Ozarks. So far, we have not been able to dig up any documented stockings above the dam, Bagnell Dam, there on the Osage River. So there's kind of an interest out there to try to go and capture one of those adults out of the lake and compare the genetics to the stocked sturgeon that we have been introducing from Wisconsin. So in 2024, we were able to put a new star on this map there in the Osage River. So this is just a quick picture of kind of what our acoustic telemetry system looks like. So we're just using VR2 TXs. There's the black cylindrical, basically submersible computers that are able to ping when a tag swims by in a fish. And also in the middle here, we have a VR100 that's just used for manual tracking. And here's just a video of kind of what these adults look like when we are trot lining for them. That's just one method that we use for capturing them in December through March in order to insert the acoustic tags, and baiting hundreds and hundreds of hooks in the cold mornings in the dark is part of that. And then also we use trammel nets and mainly gill nets as well to capture these lake sturgeon, and we do get the occasional paddlefish in there as well. And also various species of catfish, your blue cats and flatheads. So we usually are setting around 6 to 8 trot lines with 45 hooks per line. In addition, we'll typically run 3 gill nets, which are each 150 meters long. And here's just a picture of the U.S. Fish and Wildlife Service. They've helped out tremendously on this project during our adult sampling season. And here's one of them with a larger adult. So before we are able to operate on these fish, we got to get the line in the boat, and sometimes we'll have up to 8 adults on one line. So we have a holding tank there, and then we have also discovered that the patient is much more compliant when waterboarded on the operation table. And then we will check for any sort of hatchery origin indicators, such as a pit tag, coated wire tag, or scoot removal. And then we will measure weight, total length, and gill or girth measurement as well. And if they do not have any hatchery origin indicators, then we will take a genetic fin clip for genetic analysis. And we also extracted blood from around 17 adults this last spring for MDC's toxicology lab. Dr. Knott is going to be studying heavy metals and selenium of the different adults that we've been able to capture. And here's just a quick video of what that acoustic tag looks like. So we just make that incision, insert it, and then we will typically run 3 sutures to seal up that wound. And we actually have had a very high tag retention rate so far on this project. So the previous student, Dr. Michael Moore, was able to map spring adult movements. And he basically circled 3 areas here where he suspected spawning sites were spawning sites after he mapped the river. And he said typically when the water temperature is between 13 and 19 Celsius is when they were showing up in these areas, and that temperature range falls within the literature supporting that that's typically when spawning will occur. So one of the areas that he had circled there was an inoperable lock and dam structure at river kilometer 20 of the Osage River. And here's just a drone imagery shot of that. And he was able to map the entire lower 132 river kilometers of the Osage River. And this was an area that he deemed suitable for spawning. And we were able to use his bathymetry maps as well for our benthic trawling. So on April 1st, we received a phone call from the public. That individual shared some videos and pictures with us of adults thrashing about on these coarse substrates below this lock and dam structure. And, of course, we rushed down there as soon as we heard of it. We didn't get down there, though, until the 2nd. That was the soonest I was informed of it. And by then, of course, the water had risen several feet and had turned to chocolate milk due to a recent rain. So we just weren't able to see any of the activity that we were seeing on our phones that he had sent us. Nonetheless, though, we did deploy 4 egg mats. But it wasn't until about the 8th when the temperature or the water levels dropped and the water clarity improved enough to actually see, at least below the first couple inches. And on April 8th, we also had the solar eclipse occur. We'll be working with NASA here to try to replicate that here in the future, because I'll show you here in a bit what we saw on the 8th and the 9th. It is theorized by kind of the northern lake sturgeon biologists that if other environmental conditions are favorable, the lake sturgeon will typically choose the night nearest or near to the new moon to spawn, giving their milky white eggs a higher chance of survival due to the nocturnal predation. So here on the video on the left, we have kind of this rogue lone adult coming up and checking out what I ended up calling the spawning shoal. And then on the 9th, we returned to that same shoal area, as you can see there. And that morning, they were just going at it. You can see them thrashing about in the shallows there. And we were able to get some underwater GoPro footage of them spawning as well. Keep wanting to. So here we have a larger female, presumably on the left, and the male on the right, dispersing his milt into the oocytes. And that's typically that larger rock substrate. So we hopped in the water with them and began snorkeling surveys. And we're able to find up to 30 different eggs from wading surveys, snorkeling surveys, and then also collected from our egg mats that were deployed directly downstream from this location. So the U.S. Geological Survey came out the very next day with their ARIS, and were able to kind of get an idea of the number of adult lake sturgeon that were in this area. They said there was well over 100 large-bodied adults here. How many of those were lake sturgeon? We're not really sure. As you'll see here in the imagery, there definitely was some Scaphorhynchus involved at this location as well. And basically, if you're not familiar with an ARIS, it's pretty much like an $80,000 live scope unit. It's just that high-end scientific grade sonar. You can see there's quite a few fish down there on the substrate. So we used an acoustic Doppler current profiler as well to map the bathymetry of this area. And as you can see here, kind of that shoal-like area is a little bit shallower. And here we have in this image kind of the shadow being cast from a larger adult lake sturgeon there from the ARIS imagery. And so Barrel et al. 2018 documented over 40, or wrote a literature review of over 40 different spawning sites throughout the native range of the lake sturgeon. And he noted that typically water velocities were between 0.5 to 1.4 meters per second. And so from our acoustic Doppler current profiler velocity measurements, we had 0.5 to 0.9 meters per second of water velocity in this darker red area, which is moving over that spawning shoal. And our temperatures, again, were ranging right between that 12 to 17.5 degrees Celsius. So all factors lined up that this was favorable. And then we also measured velocity with a flow mate as best we could across this spawning shoal with that flow mate, and that was 0.6 to 0.85 meters per second. So again, right within that threshold that Barrel et al. Had indicated. And so those areas that you saw that had that darker red were containing substrates that were lacking that biofilm. And that's this rock here in the top right. And if you look closely, you'll see there are some eggs even sticking to that up there on the top right. Those were likely blue suckers. We had blue suckers in there too. I was practically tripping over them, walking around doing the wading surveys. Areas outside of that intense velocity, we have substrate that had this biofilm on it, as you can see here from my hand. And we did not find any eggs on those rocks, nor did we find any eggs on the egg mats we had stationed behind areas like these. They were definitely keying in on these areas that had the cleaner substrates. Whether they realized those substrates were clean or whether they realized that that's where the favorable velocity was present, I'm unsure. But it was interesting to note that we had a very large distinction between the biofilm that was accumulating on these substrates. Here's a picture of a lake sturgeon egg here on the left from one of our egg ramps. And then on the right, we have just a rock that was just loaded full of blue sucker eggs there. So we also were able to map with side imaging the substrate that was here, trying to characterize it. And these metrics were also taken from Barrel's publication. So we had gravel at 16 to 64, then cobble and boulder. And our substrate was right in line with that, primarily being dominated by your cobble to boulder. And here's just another screenshot from the AIRS imagery that was kind of stationed just below that spawning shoal. You can see that larger boulder to cobble substrate there with 1 to 2 adults suspended above it. So we had about 5,000 CFS rolling down the river while these sturgeon were spawning, and that resulted in roughly around 0.6 meters per second, which is that within the preferred range for sufficient egg aeration. And unfortunately, just a few days after the last spawning occurrence, which was on April 15th, on April 21st, the dam upriver, Bagnell Dam, cut the flows down to 1,000 CFS. We rushed back out there to measure what the velocity did. And obviously, as you can see here, we have no spill coming over that dam, and we had 0 meters per second for water velocity, which was detrimental. The water dropped. We had eggs on these rocks that are high and dry in this photo here, which was a little disappointing. On the 24th, just 3 days after we had that, just 3 days after the flows dropped, I did another snorkel survey. And as you can see here, this is just one screenshot of the many of 3 eggs that were buzzed over, and they likely died due to developmental arrest. Forsyth et al. 2013 noted that in a controlled study, typically the majority of developmental arrest resulted due to lack of egg aeration. And here's sturgeon from a lab. And as you can see, at this age, when they do hatch, they're pretty vulnerable. You can see the heartbeat going there. It's pretty neat. But that's when they are settled out into that interstitial space, and they still need that velocity while they are developing that egg yolk sac prior to the onset of drift. So Mother Nature set up almost like the perfect funnel for us right here, pretty much in the center of this dam was where that spawning shoal was occurring. In fact, if you look close, you can see some of my buoys off the egg mats there. So we stretched a cable with 12 larval nets hooked to it across there. And we got that in on the night of April 19th. And we were lucky we got it in that early, because that was the night when we caught quite a few of our larval lake sturgeon. And then the very next day on the 20th, we caught quite a few more, being 17 in total. 15 of those came on the 19th and the 20th, and then 2 more came through on the 25th. So that was after the 25th, remember, was after they cut our flows, which was remarkable. We had at least a few survivors, but obviously would have been ideal if we could have had the flows maintained constant at least 3,000 to 5,000 CFS. So here's what a larval lake sturgeon looks like here on the left, and on the right here is our cable that we had stretched across the river there, buoys marking each net in case the public messed with them, because this is a very popular fishing area, and that cable rested across the substrate, so it wasn't up high, harming anyone's prop. And here's just us pulling those larval nets. So here's a hydrograph of what we had occur there on the Gasconade and the Osage River. We see these 2 spikes early on in April of flow, which likely cued these patagamous species to migrate upstream to spawn. And then also that F4 that I showed you, that gravid female, She was tagged in the Osage River last December. She left the Osage River in February, went down to St. Louis, and then returned back up the Missouri River and swam over 100 river kilometers up the Gasconade River with 5 of my tagged males with her. And then that was the first week of April. April 2nd was the last time I think I had pinged her. And then shortly thereafter, I think it was April 7th, she blew by my receiver and showed up down at the confluence of the Gasconade. Within 5 days, she covered 100 river kilometers. Would have loved to have captured her and assessed if she was undergoing follicular atresia or if she did indeed expel her eggs, but it's one of those scientific questions you'll never know. So this was a big deal for the Missouri Department of Conservation. This was at least to the extent of my knowledge, the first documented spawning occurrence of Lake Sturgeon within the Missouri River watershed. And this is the deputy director. He came out on April 9th when they were spawning, and he actually used this picture for his announcement to become the new director of the Missouri Department of Conservation. And this 2024 marked 4 decades of MDC's Lake Sturgeon restoration efforts, and we are finally starting to see some of the fruits of the labor pay off. But so that kind of leads us into the next question for my dissertation: is recruitment occurring? If not, why not? And what's happening in this in-between stage of, we captured larval lake sturgeon, where are they going, and why are we not able to find them as age zeros? And so, yeah, my second chapter is to determine the summer and fall distribution habitat use of these age zero lake sturgeon. So to do that, we are using a benthic trawl. This is a mini Missouri trawl. There on the bow of the boat, you can see. And then over here on our Mesa tablet, we are using Dr. Michael Moore's habitat rasters that he created, and also his bathymetry maps, to try to target these areas where we suspect a habitat to be suitable later on in the year, since he only created age zero winter suitable habitat. But we do use his bathymetry maps during the summer and fall to try to locate where these deeper areas are, since they were negatively phototaxic during the onset of drift. Maybe that's a trait they are carrying into the months following that and those life stages. And so we also are using a side scan sonar. This is specifically a Lowrance, to try to avoid these trees, boulders, anything that's going to snag up this trawl. And we do record each trawling transect in order to be able to replicate that in case we ever do find one. And then we use an app on our phones just to record these trawls. We typically keep them in between 100 to 120 meters, just for that consistency over time. So the previous students here at the co-op unit were able to find age zero lake sturgeon while benthic trawling in the Gasconade River. And typically, though, that was post-stocking. So they're able to find them when we stock them, but we haven't stocked them in the last few years in either of these rivers. And we've kind of been struggling to find them so far. However, we are collecting data on native species, and one of these species here in the lower right is actually a crystal darter. That's a state endangered species. And then here in the upper right, we have the Alabama shad, which is under review right now for petitioning on the federal endangered species list. The Gasconade River is actually one of the furthest north rivers where this species is known to occur. And here's just a map of how many benthic trawls we've been able to accomplish so far. We're at 500 plus trawls and counting. And we found one age zero sturgeon, although is likely is obviously a Scaphorhynchus, not a lake sturgeon. So kind of to sum it up, what we've learned about Missouri lake sturgeon: adults use these rivers. We've documented spawning in the Osage River, collected drifting larvae, and now the next goal is to find these age 0 to 1 juveniles. But so far, we've yet to discover one. So we have an upcoming new project, which is identifying the availability of thermal refuge for the young of the year lake sturgeon. And one factor to take into consideration here is we have the Osage River up on the upper left here, Gasconade River in the lower right, and Bug et al. 2020 documented acute thermal maximum for these 60+ day-old lake sturgeon was about at that 32 degrees Celsius, otherwise 90 degrees Fahrenheit. And you'll see here the Gasconade, we're meeting that almost annually. The Osage River is pushing closer to that. It is Bagnell Dam is a hypolimnetic release. That's a benthic release. So we do have a little bit cooler temperatures than your shallower natural river like the Gasconade. So many of you have probably seen this from your undergrad ichthyology course. So on the y-axis, we have performance, and then the x-axis, we have temperature. And so we have that critical thermal maximum there on the far right and critical thermal minimum on the far left. And then you have your temperature where optimal is present there with performance max. It's kind of right in that sweet spot. And we're basically wondering, what temperatures are these H0s selecting for? When we have stocked these in the past, Dr. Michael Moore noted that less than 20% of stocked fish left those tributaries here on these graphs here on the right. And the activity center actually converged into that, I think it was around RKM 50 to 30 on each river is where those fish kind of gravitated towards, which is very interesting. So kind of defining what is refuge. We have weather, flow, groundwater, shade, oxygen, and we're going to be using the USGS data loggers, National Weather Service. We just deployed a dissolved oxygen sensor, otherwise a hobo logger, in one of the areas where we have concerns. And then we're obviously taking field observations. And here on the right is a photo of trout and a groundwater upwelling in a river. They are obviously aggregating in this area where that thermal temperature is more favorable to them. And we do have a YSI that will be dropping down into some of these areas. And one of these areas, being in the Osage, is a dredging hole where we do have lower dissolved oxygen levels. Here you'll notice on the right. And it's been documented that less than 25 degrees Celsius is preferred with DO above 7 milligrams per liter. And so we're guessing that that's kind of the suitable area for these H0s. So the project objectives for this upcoming new project is to document existing environmental conditions and targeted river reaches from June through September. And then also the second goal will be to document movement, habitat used, and survival of transmitted and stocked small fingerling lake sturgeon, and then compare the habitats used versus what is available. And to do that, we're going to be using JSATs, otherwise known as juvenile salmon acoustic transmitters. And we'll be using remote receivers deployed to identify fish leaving these areas. And then also we'll be completing manual tracking every 3 to 5 days in areas of congregations. And that'll be July through September of 2027 to 2028. Let's see. So the conclusion will be enforcement of spring regulatory flows from Bagnell Dam. I think pretty much every river researcher would love the dam upstream to work with them. And check, all right, I'm good on time here. So, and then low flow nursery habitat identification obviously is another need that we need to identify. There's been an 86% reduction in low velocity habitat throughout the Missouri River since it's been channelized. And then identification of these thermal refuge areas. And that's kind of the project that I just spoke about, is the H0 thermal ecology study that was just pitched to the Missouri Department of Conservation. And so far it seems as if it will be funded. We'll be finding out here, I think, relatively soon. And just acknowledgments, I'd love to thank all the people who have helped on this project, all of the organizations that have awarded me scholarships or fellowships. It's been tremendous to see the amount of people that care about lake sturgeon and want to get out and work with lake sturgeon on this project. and the U.S. Fish and Wildlife Service. You see a lot of those names up there, and then the USGS for sharing their ARIS imagery with me, and also their larval net, letting me borrow their larval nets. And my technicians, Chad Boney and then Antonio Medina, have worked tremendously hard on this project. And with that, I'll take any questions. Thank you.
Thanks, Levi. Yeah, good, really good stuff. A lot of good work being done down there. So glad to hear more about it.
Yeah, it's been a fun project.
I had one question. I know you mentioned about like the spawning sites, like having different like qualities of substrate, like the biofilm. Uh,
Sure.
could it just be could they be spawning in the area where there's still that biofilm present and the fertilized eggs just can't adhere to it, so they just like get swept away? Or do you think
Yeah,
they're actually like favoring the different flow conditions and like substrate conditions?
sure. I mean, that is entirely possible. We did have egg mats deployed behind those areas where the substrate had that biofilm on it. While we were present there, we didn't see any of that thrashing, spawning activity occurring on those areas. But I mean, we weren't there during the night, and we weren't there during all daylight hours. So it's possible that they were spawning in those areas, and it's possible our egg mats missed them,
Hmm.
missed any eggs that might have been in that area. Um, yeah, that's a great question. Hard to say for certain. All I can say is we didn't see any spawning activity in those areas or find any eggs in those egg mats that were deployed there. And I didn't find any kind of in those tucked, crevices when I was doing the snorkel surveys either.
Right.
Yeah, it's not to say that they're not.
Yeah, I know it's kind of a hard question to answer. You can't really
Yeah,
be entirely sure, but yeah. And then for like the dam on the, is it the Osage one that
yeah,
is the idea behind that where you could like coordinate with the dam operators and be like, from this time window, we need or would prefer to have like certain flow conditions so that in the event that there is successful spawning going on, that they aren't just like you said, left out of water if flow conditions
sure.
go back down to normal.
Right. Yeah. So if you look at this hydrograph, we actually had to pull our equipment on April 30th, that cable, because we had around 50,000 CFS coming down that river. We went from 1,000 CFS there on April, what was it, April 25th, to 50,000 less than, a week and a half later. Um, so yeah, I mean, we would have loved to have seen, a little bit more water coming down the river during that mid-April range. But I contacted the lake sturgeon kind of lake sturgeon lead recovery biologist for the state, Travis Moore, and told him, I said, hey, this is what the predicted flows are reading. He contacted his contact there at the dam, kind of let them know what we had going on, and we didn't get the flows. I don't know exactly um what he's told or asked or requested or anything, but it was disappointing to see, during those snorkeling surveys post spawn, seeing that many fuzzed over eggs. I just showed you guys three. There was quite a few in that area.
Right.
Um, Likely died due to developmental arrest from lack of flow, as you saw.
Hmm.
So yeah, that is something that I hope, and the relicensing of this dam, when that comes available, I hope that will be something that we're able to get worked in there, is some sort of minimum flow requirement for the Osage River. And this lock and dam structure that's no longer it's inoperable. There's been talk for, I think, close to 2 decades, Dr. Pockert has told me, of removing that dam. So if that is to occur in the future, perhaps turning it into some sort of artificial spawning habitat would possibly be on the docket. Looks like, do we have 2
Yeah, I think you
chat
kind
here?
of touched on it. It was basically, like, what's the likelihood that, dam operators would be
Oh,
cooperative with like the idea of controlled flows and that kind of stuff?
sure. Yeah, no, that's yeah, excellent question. I really hope that the Missouri Department of Conservation will be able to work with them on trying to get a some sort of an agreement worked out. I mean, that'd be ideal, because if you could cue spawning with that spring pulse to get those adults to move up the river, um, it'd be ideal, and then obviously have something less or greater than 1,000 CFS to maintain that velocity threshold would be great. It's a little above my pay grade to call down there and say, hey, here's what you should do. But yeah, a lot of politics involved when you talk about water,
Yeah, yeah.
fortunately.
Yeah, I can chime in here a little bit with from Amy's question about the dam operators and yeah, Levi, like you're right. There's there's a FERC relicensing that the dam has to go through every 40 years, and I think we still got like 10 years, maybe even a little bit more before that happens. But the Missouri Department of Conservation, the equivalent of the DNR down here, has been doing several studies related to flows and fish to try to kind of build this evidence to make recommendations to them. They actually have modified their flows in the past, more their ramping rate, so that like it doesn't dry up as fast as it used to. But not so much for sturgeon, but for other species in the area. It's a private company actually that owns the dam, Bagnell Dam, which is kind of interesting. But one thing that surprised me in a good way is on the Mississippi River. Um, Levi mentioned that there's been some fish spawning below this Mel Price Lock and Dam, which is one of the last lock and dams on the Mississippi. The Army Corps of Engineers is actually working up and down the Mississippi now to provide flows suitable for lake sturgeon spawning on the Mississippi River below that Mel Price Lock and Dam. I don't know the details of where that sits, but I know that there's support for it from the Army Corps, and now they're just trying to work out all the different lock and dam structures all the way up to the Twin Cities on how do they do that. But it's encouraging.
Yeah.
Um, Hi, Levi. I had a question. This is great. Thank you. I was wondering if you could speak a little bit to, you mentioned kind of like the restoration aspect and kind of 4 decades of restoration work centered on Lake Sturgeon. I
Sure.
was curious, I'm familiar with the stocking side of things, but I was curious if there were kind of other elements of that restoration and what that looked like.
Right. So we were originally well, I think we continually are sourcing our lake sturgeon fry from Wisconsin, and there's talk of beginning to source our own brood stock here within Missouri that have grown up through our warmer waters, and using that brood stock that's, hopefully somewhat adapted to the warmer environment down here, and using those to breed in the hatcheries and then stock those. As far as other restoration, as far as like artificial habitat, I don't think there's been a whole lot of that in these rivers. I can't remember if there was some talk of that in the Osage River. I can't remember the gal's name off the top of my head, but as far as the potential of removing that dam, um, perhaps trying to make that into an artificial spawning structure there would be ideal. Yeah, I don't, Craig, do you know if has there been any other restoration efforts besides stocking that has occurred as far as like habitat wise?
Not that I'm aware of. A lot of it
Yeah,
has been the stocking, which they started in '84, and now that these fish seem to be showing up and anglers are catching them, there's a little bit more interest in it. Um,
right.
So the one plan that they do want to do is look at some of the habitat conditions in these rivers, and then go to other rivers where Lake Sturgeon have shown up sporadically as well. That actually might have better water temperatures, more cooler water temperatures, and just to see if that habitat exists in some of these other rivers, and like one's called the Merrimack River.
Yeah.
And if not, would they actually then create a habitat, for, more like gravel habitat for spawning? They're doing that for other fish below, like they're adding substrate to other rivers not related to lake sturgeon, but this is something they've been doing. But that's ultimately, I think, what they want to do is try to find more areas where lake sturgeon do actually have the ability to spawn.
Well,
And
thank you.
the Merrimack River is a river that has some springs in it, so slightly cooler water temperatures, and that is for the second year of this age zero thermal ecology study is one of the rivers that is included in that for stocking age zeros with the JSATs. Be interesting to see what comes of that.
One other interesting thing about that old lock and dam structure that where Levi found the fish spawning, like you said, this thing's over 100 years old. There's no use for it anymore, but it's controversial as far as removing it because the local landowners like there's a nice kind of pool or pond above it, where they can fish. But one thing that the U.S. Fish and Wildlife Service told me several years back is one of the concerns is they don't actually know who owns the dam. Apparently, there was maybe an agreement years and years ago from the federal government to deed it to the local landowners around there. But then there's some questions on even if that was legal. But so some of the things that have come up with this is they got to figure out actually who owns it before they're sending modifications to it. Now, something when they told me this, like this should be a pretty easy question to answer is who owns the dam, but it's not.
You know.
Yeah, I mean, if there's not any other questions, I guess we can wrap it up here. But thanks again for Levi for coming on today and telling us more about his project and the important work that's going on in Missouri.
Yeah, thanks for listening, y'all. It's the longest presentation I've ever given sitting down. Typically like to walk around a bit.
Yeah.
Mhm.